Hello everybody, welcome back to another higher maths lesson. Today we are 1. Outside, Shockcorra in Scotland, and 2. Still looking at recurrence relations. So this time we're going to solving recurrence relations to find A and B. So this is something that's slightly different to what we've done so far. So we have a recurrence relation which is defined by the normal way we do a recurrence relation, which is un add 1 equals a un plus b. So this is the standard way we write out a recurrence relation when we don't know the values of a and b. Normally we're used to already having these values, but today we're actually going to calculate them. So this is what the recurrence relation will look like. We are going to be told 3 consecutive terms of the recurrence relation, and once we know that, we could then use that information to actually calculate the values of a and b themselves. So I'll show you how this works. Now, I've stressed many times on this topic that what we do is we use the last answer to get the next answer. So in this recurrence relation, we would use the answer to u1 to get the answer to u2. So the recurrence relation would look something like this. And also, we would then use the answer to u2 to get the answer to u3. So u3 would equal a times u2 plus b. Now, if I pop in these numbers into this 2 equations here, look at what we get. So u2, so that's 9.5 equals a times u1, which is 5, plus b. Now, that, I could rewrite that, I'll do that in a minute. u3, 20.75 equals a times u2 plus b. Okay, now these 2 recurrence relations, I'm just going to write them out slightly differently. So I'm going to have 9.5 will equal 5a plus b, and we will have 20.75 equals 9.5a plus b. Okay, so we have 2 equations happening at the same time. We yet again have simultaneous equations. In fact, we've got very easy simultaneous equations, because if I simply take these equations away from each other, b will be eliminated immediately. We don't need to multiply them by anything like that. So what I'm going to do to avoid negatives, I'm going to do the bottom take away the top. So if I do that, 20.75 take away 9.5 is going to equal 11.25. 9.5a take away 5 is going to equal 4.5a. The b will disappear because they eliminate each other, and then we don't need to think about them anymore. And then what we'll need to do is we'll need to try and solve this. So we'll need to use your calculator to get the answer. So I'm going to have to divide 11.25, and I want to divide that by 4.5, and that gives me an answer of 2.5. So a will equal 11.25 divided by 4.5, which is 2.5. And then, just like with any recurrence relation, I'm going to go back into either of these 2, substitute the a value in, and work out what b is going to work out to be. So 9.5 equals 5 a's. If I do 5 times 2.5, that's 12.5. And then if I take 12.5 away from both sides, I get the answer that b is minus 3. So I've worked out what a is, I've worked out what b is, job done. Right, next example, same as before. We're going to use 3 consecutive terms, and we're going to try and work out the values of a and b. So I've actually got the same as u1, u2 and u3, so I'm using these 2 equations again. To get the answer to u2, I must use the answer to u1. So that will be 0 equals, now in the last one I did a times 5, and then I had to switch it round. So we'll just switch it round immediately. So it's going to be u1 times a. So that'll be 100a plus b. And we do the same with the second one, so I'm going to use this answer. Now, 0 times 100 straight away, that cancels out. I'm just left with B. So this is a funny one. Because of the use of 0 as one of the answers, we straight away go to an answer for B. B is minus 50. So I don't need to do anything else here in terms of working out what B is. All I need to do is go and work out what A is. So that is going to be substituted instead of B. So that will give me 0 equals 100A minus 50. I will add the 50 to both sides. So 50 will equal 100A. I'll divide by the 100. So A works out to be a half. So we've got B is minus 50, A is a half, and we're all done. Then we'll try another one. So this time I'm changing the recurrence relations, the terms that we've been given. We've got U11, U12 and U13. And I'm going to find the values of A and B. So this time it would be U11, which would be used to get the answer for U12. So 10.2 will equal 0.8A plus B. And then I'm going to use 10.2 to get the answer of 12.55. Like so. Straight away I can take the equations away from each other to eliminate the B. So 12.55 take away 10.2, that's going to give me 2.35. 10.2 take away 0.8, that's going to give me 9.4A. Okay, to get the answer for A, I'm going to have to divide by 9.4. So you'd have to use your calculator for that. 2.35 divided by 9.4 works out to be 0.25. And now I'm going to go back up to one of my recurrence relations. I'm going to take the top one and I'm going to sub in the A value. So 10.2 is going to equal 0.8 multiplied by 0.25 plus B. 0.8 times 0.25 is 0.2. I'm going to take the 0.2 away from both sides to get B equal to 10. Job done. Right, your turn. I want you to try question number 4. Same as what we've just done there. Hit pause now, give it a go. Right, so what we should be doing is we should be using U1 to get U2. So it will be 10 equals 12A plus B. And then I'm going to use U2 to get U3. Like so. Take the two equations away from each other. And I'll be left with 2 equals 2A. So A is 1. If A is 1, go back into either equation and sub the value in. I'm just going to take the bottom one this time. I'm going to replace A with 1. So I'll get 10 times 1, or I'll just write 10. And then I'm going to take 10 from both sides. B equals minus 2. And then just one more for you to try today. Let you get outside in the sunshine. I'm giving U3, U4 and U5, and again you've got to find the answers for A and B. Hit pause, on you go. So same as previous, I'm going to use U3 to get U4. So there's U4. And that's where U3 will be subbed in. And then going to use U4 to get U5. And we get this. I'm going to take the equations away from each other. I'm going to do bottom take away top to avoid negatives. 21A take away 8A. B take away B eliminates B. To get the answer for A, I'm going to divide by 13. And that works out to be 2. I'm going to use the top equation. I'm going to sub A back in there. So A is 2, so I'll get 8 times 2 plus B, so that's going to give me 16. Take the 16 away from both sides, B equals 5. And that's it, people. We didn't say higher maths was always going to be that hard, so we are using 3 consecutive terms to find the values of A and B in a recurrence relation using simultaneous equations. Really important you're good at simultaneous equations. Obviously it's come up in the straight line and recurrence relations. So get practicing, and we'll see you in the next lesson.